Okay, so yeah, we are looking just now at practice unit test for the CFE National 5 expressions and formulae. So obviously you'll be given the formula list in case you need them. So that's part of the paper. So the first one that we have here is we were asked to simplify giving your answer in sub form for root 32. So whenever I see something asking me to simplify a square root, I'm looking at square numbers. Okay, so if I were you, what I would do is I would put on the side of my paper a few basic square numbers. So the basic one, obviously, apart from 1 square, I would write on the side of my paper things like 4, the next one 3 times 3, 9, then 4 times 4, 16, and the next one 25. You can go up to 36 if you want. So this is what I usually would do. I would look at my number here, 32, and I would see, is there a number that I can time it by that will use one of the square numbers here? So I'm looking at them. First of all, 32 is even. So that means it's a multiple of 2. But if I half it, I get 16. I can half it again. So that means it's a multiple of 2 times 2, which is a multiple of 4. So maybe I can use 4. And this is what you would do. You would say, okay, 32 is 4 times or 16 times 2. So you can just keep going. So let's say you would go 32 divided by 2 is 16. So 16 times 2, 32, and you see it straight away. If you hadn't seen it, you would say 16 is 8 times 2.
So you just look for the common factors, then just find the highest square number, if that's correct.
So if you would do something like this, you can say, okay, so 8 times 2 times 2, but you've got root of, so 8 becomes now your 4 times 2 again. Can you see it? 8, you can replace that by 4 times 2 if you wanted to.
Yeah, that would be 4 root 4 times root 2.
Yeah. So now you get 2 times 2, which is 4, like 2 square, and another 2 square. And now you can say, okay, I've got enough here. I can replace root 32 with 4 times 4 times 2. If you hadn't seen that 16 is 4 square, now you can see it straight away because you went 4 times 4 times 2. And because you've got a 4 square here, you can just take it out from the root, and that becomes 4 outside root 2. Yeah? So that's why when they mark you here, it tells you either you see it straight away as root 16 times root 2, but if you hadn't seen it, it tells you you still get a mark if you get equivalent. So if you had gone 8 times 2 times 2 or 4 times 2 times 2, you will still get that 1 mark.
Adrian Kirsty's just looking to get back in, if that's okay.
Okay, let me add her back in. Yeah, so I think I've got Andrew and Kirsty. Okay, so that's why I've got you here in the side of the paper, the marking, how they do it. Okay, so you would go 2 marks. But even if you had just come and say, oh, I can see this is 4 root 2, you will still get your 2 marks. Okay, but if you hadn't got 4 root 2 and you only put root 16 times 2, you would just get 1 mark. Okay, so the final answer here would be 4 root 2, because we know that root 4 square times root 2 is just 4 root 2, yeah. Okay, so that's how you would get your 2 marks, 4 root 2, or only 1 mark if you leave it like this. Yeah, so these are surd. So surd is something that we need to manipulate, and root 2 is a surd, so we leave it. This is the simplest form we can give it back to. Okay, so the second question we've got is manipulating indices. So the rule of indices used to tell us that if you got a base and an index time another the same base with an index, you can just add those numbers together when you time them, but when you divide them, you take them away. So basically this would be x to the power 4 plus 6 minus 3. So 4 plus 6 is 10. 10 minus 3 is 7. So your answer should be here, x to the power of 7. Okay. Or if you would rather simplifying this, you can just say I've got x to the power 6 and x cubed. I can decide to simplify x cubed and x to the power 6. It's like 6 minus 3, x to the power 3 at the top, and 3 plus 4 equals 7. So that would be another way of doing this. Okay. So we know the rules, yeah?
Yeah.
Or if the worst come to the worst, you can type x times x times x times x 4 times, then type x times x times x times x 6 times, and at the bottom x times x times x, and start cancelling one, another one, and another one, and you'll end up with x to the power 7. So you will still get the mark. So that's really if you can't remember the rules of indices. Okay, that becomes a bit harder here now because we've got indices that uses fractions. So the first thing first is we need to time 5 and 4. So that'd be 20. And then I've got x to the power 4 times x to the power negative 5 over 2. That's a negative, just in case we've not seen it. So then the answer here would be 20 that would be 1 mark, x to the power 4
Negative.
minus 5 over 2, yeah. So now we need to solve this. 4 take away 5 over 2. So you can think about it. 5 over 2 is 2.5. What's 4 take away 2.5?
2.5.
2. No, 2. 2.
Or 1.5.
1.5. So you can say, okay, that's x to the power 1.5. But if I use fraction, 1.5 is 3 over 2. So technically, you should give me that at the end as 20 x to the power 3 over 2. But you need to show me that you can have this 4 minus 5 over 2.
You do 4 over 1, couldn't you, essentially, then make it
Correct.
2.
So this is how you do your common denominator. You do 4 over 1.
Then is it the smell? No,
Yeah, no, yeah, to add them up, you can say, okay, I'm going to do 2 times 4, 8 minus 5 divided by 2. So you can do the kiss and smile. Yeah, so 8 minus 5 is 3. Or you can just say, I'm going to time this bottom by 2. That will give me 2. And I'm going to time this one by 2. That was going to give me 8. And now you've got the common denominator. And 8 minus 5 is just 3 over 2. Okay? And now you've got 4 minus 5 over 2, which is just 3 over 2. And your final answer should be 20 x to the power 3 over 2. And make sure when you write indices as well, it's top left, top right of the number. So let's see how they mark these. So for the first one there, we had x to the power 4 plus 6 minus 3, x to the power 7. So you get your 2 marks there. Another mark would be gained if you do 5 times 4, which is 20. Then x to the power 3 over 2 in answer, 20x to the power 3 over 2. So that's how you would get your 4 marks there. Yeah, so 4 plus 6 minus 3, 2 marks. 20, another mark. X to the power 3 over 2, another mark. Okay. So now we've been asked to give an answer in scientific notation. So this is where you're going to use your calculator. So far we didn't need to use our calculator. But remember, this exam is with calculator. So you could be, you see where it says here 4 minus 5 over 2? You could be using your calculator and do 4 minus 5 divided by 2. And that would be 3 over 2. You can check your answer as well. So this time we've been given 3.12 10 to the power 4. So you just type 3.12 x 10x to the power 4. So the number of people. Each person paid 27. So the whole thing, you time it by 27. And the answer I get is 842,400.
Yeah.
So 842,400. Yeah. So, but remember the question, give your answer in scientific notation. So what we said was to give an answer in scientific notation, this is the scientific notation style that we expect you to give your answer into. So you just write 842,400. So that's 842,400 pound. So now you put your decimal point there. Have you noticed that the scientific notation is between 1 and 9? So you need to give me a number back between 1 and 9. So by taking your decimal point, you're going to move it 1, 2, 3, 4, 5 position. So you just rewrite this as 8.424 times 10 to the power 5, because you've moved it by 5 position. And you can quickly check it with your calculator. So if you do 8.424 10 to the power 5, and you do equal, and it should get you back to your 84240. So the good thing about unit assessment, because you're allowed a calculator, you can check your work as you go through it. Okay, and because we talk in money here, we need to remember to give our answer with a pound sign in front there.
So see how you're talking in money, why would you not just put that as 8.42 times 10 to the power of 5?
Because if you give me 8.42, you give me only 3 significant figures. So you still want to
because
know.
it's already asking for the first part
Yeah,
of that question.
they're asking us for how much money basically the stadium has made. If you just say 8.42, someone has just put £400 in his pocket and just said that we made 8.42 to the tax office or something. Whereas if they give 8.42 for 10 to the power 5, they'll know that they've made £842,400. But to be
Okay.
honest, if it's real life, they'll give it to the, in £1 million, or this is more like them trying to see, can you write something in scientific notation?
I had 8.4 times by 10 to the power of 5 and 8.4. £8.4 being the.
So the problem, yeah, if you just put 8.4, you've rounded it, and they've not asked us to round it. So if they had asked you, give your answer to 2 significant figures, yeah, you would stop at 8.4. 3 significant figure, 8.42. But because they've not told us to round anything, we just go to the maximum number of significant figure here is 8.424 and 00. Okay. The next one is expand and simplify. So we've worked on those before. D times 4D minus D times E. So yeah, 4D square minus ED or minus DE. Shouldn't make a difference. That would be for the first one. For the second one, you need to time G with G and G with 9. So 9G, and then we finish it off 4 times G and 4 times 9. And after that, remember it says expand and simplify. Then you would simplify because you get a 4G and a 9G. So 4G plus 9G would be your 13G. So there you go. You get 1 mark for 4D square minus DE or minus ED, same thing. The next one you get a mark by doing G square plus 4G plus 9G plus 36. That'd be another mark. So you need every single item there. So if you only give G square plus 4G, unfortunately in math, they don't give half marks. Okay, so you need to have the full thing to get the full mark. And then after that, your last mark would be to now group the likes, 4G and 9G. You simplify it as 13G. Okay. So far that should be so good. Now the next one, we had a question with where we were asked to factorize. So here you would look for common factors, and we've got only letters here that are common to each other. So the letter that is common is Y. So you would get Y outside and open your bracket. Y times what give me Y square?
Y.
Y, yeah. And Y times what give me -6? Y is just -6.
-6.
Yeah, and you can quickly check it by doing what we did here with the D times 4D, Y square minus 6Y. Then you come out and you know that this is correct because you've checked it. Okay.
Yeah.
The next one, remember when I said write down a list of the common squares? So 6 times 6 was 36. What's 7 times 7?
49.
So yeah, I would argue that maybe you should just keep going with that. 49 and then 64. Put it on the side of your paper.
Just write them all.
Yeah.
Tattoo them on your forearms.
And then 81. in case you forget about them. 81. Yeah, so it's a good thing to just write them because when it comes to factorizing, you'll be able to see straight away, oh, I've got 49 here and I've got 49 here. And that might just ring a bell to you. That 49 is 7 square. Okay. So I've got a square and another square number, and we've called this difference of two squares. And to factorize this, you open a bracket, you do t plus 7 for the first one, time t minus 7, yeah. So we've done quite a few of those. And that should give you the mark. I think you get 2 marks for this one. I'll put the answer on the right. Then the last one. Okay, the last one is we need to find 2 numbers. If I time the 2 numbers, I get 12. And when I add the 2 numbers, I get 7. So what are those 2 numbers?
4.
So 3 and 4, yep. So 3 plus 4 give me 7. So you open your bracket. You don't really need to use MAM here because the coefficient for the x square is 1. So you just put your 2 numbers there, and they're both positive. So x plus, so we said 3 and 4, x plus 3 times x plus 4. So in the unit assessment, you don't need to use MAM really. So we are using MAM, but with a coefficient of 1. So usually it's always a coefficient of 1 for the C level. So when you get to A mark, for example, then you'll have 2 here, and then you can start using MAM to factorize after. So let's see how they give the points for this. So the first one, y minus 6, so that's 1 mark. Next one, you only get 1 mark because it's the difference of 2 square, t plus 7, t minus 7. I think once you find 7, you get that. The next one, you get a mark to just write x3 and x4. And then you get your second mark if you put the plus in front of both. Yeah?
I wrote it, I just wrote it out. I don't know why I did this, but I wrote x squared. Well, I did x squared plus 3x plus 4x plus 12. I knew that 3 and 4 were the 2 numbers that I needed to extract that, like,
Okay.
factor in. I've obviously made it out incredibly.
Okay, so remember I always say you're gonna get plenty time.
Check it.
Did you get g plus 4, g plus 9?
Yeah, I did, yeah.
So now is the time where once you write your answer, you go x times x, x squared. X times 4, 4x. X times 3, 3x. And 3 times 4, 12. So this is the time where you're going to write all these and then check that you've got the same answer as the question the function you were asked to factorize. So if you had put x squared here and then put x here, for example, or x squared again, x squared times x squared is x to the power 4. And that should be telling you, oh, I've not got a power 4. There's something here that I've done wrong somewhere. Okay, so it's the bit that we say to check. I know difference of 2 squared you probably don't need to check, but you do, because t times t is t squared. 7t minus 7t is 0t, and then 7 times negative 7 is your minus 49. So even that, we should, if someone asks you, did you get it right? You would say, yes, I did, because I checked that I'm back to what I've been asked to factorize. Yeah, so there shouldn't be any excuse to say, I don't know what to check, because you just go back to expanding, factorizing. It's just the opposite of the other one. Okay.
No worries, thank you.
No worries. So the next one was completing the square. So we've done quite a few of those. So this is the bit where we looked at the coefficient of x and we halved it. Remember that? So we said that p was 3 because you've halved this coefficient here. So you can start writing, this is x plus 3 square. But because you've added plus 3 square, you need to take away 9. And then you put your plus 7.
I had plus 7 to start with, but then...
So yeah, you need, because what you've done here by doing x plus 3 square, technically you're doing x square plus 3x, that's plus 6x plus 9. Because we've added that 9, we need to take that away. Again, you can check it to see if it works by expanding this, and you will notice that the 9s and the 9s will will cancel each other. And now you've got your x plus 3 square. What's minus 9 plus 7?
2. Negative 2.
Negative 2, yeah. So that's your final answer. X plus 3.
I did it with plus 7, and then I went with plus 7, take away 9.
Yeah, that's fine. You can do it that way. You still get the same answer.
I almost forgot to square the coefficient after.
No, I think you'd be okay to write plus 7 take away 9.
Yeah.
Some people just write plus 7, and then because they said, oh, I've added 9, I need to take that away. I like to take it away straight away because it reminds me, oh, you've added a 9, so you need to take that away. But then you need to remember to add the 7. Okay. So let's say you get this question, you can't remember that you need to halve the 6. What can we do? Can you expand x plus p square? So x plus p square is x square plus px plus px, that's 2px, plus p square. Do you agree? I've just expanded, yeah, so x plus p square is x times x, which is x square, plus px, that's 2px, plus p square, plus q, plus q. So let's say you got a blank during an exam one day. They've asked you to look at this and make it like this. I've got a 1 in front of the x square. I've got a 1 in front of the x square. Now, 6 equal 2p. What is p? If 6 equal 2p,
3.
yeah. So that 3 here that you knew because you've been learning it by heart, you could find it straight away by expanding this and say, oh, I need to have the coefficient of x 6, as they've asked me there, but 2p is 6. So what is p? P must be 3. Yeah?
Yeah.
So there you go. You've got 2p equals 6. P equals 3. Because you just divide by 2 both sides, right? You know how to solve these. Now, I've got p squared plus q equals 7. Yeah? To still be on that same, so this is plus p squared plus q. That needs to be equal to 7 if I want this function to be equal to this function. What's p squared? 3 times 3. So 3 times 3 is 9. So then you write 9 plus q. I hate 9 and q because they're so similar. 9 plus q equals 7. So 9 plus q equals 7. You take away 9 on each side, and that's you. You've got your q. What's 7 take away 9?
-2.
There you go. Now, did you see? We got our answer a long rooted way, but it's exactly the same way. Here, you learn a technique. Here, you look at something you've been given, You expand it, and then you associate each coefficient to be exactly the same, and you will get your answer. And I'll give more credit to someone going through expanding and trying to figure out what it's doing than someone learning by heart, oh, I need to have this. Because sometimes they don't know why they've got to have it. But if I tell you you have it because 2p is going to be that number, that's why we have the 6. Okay? So if you start drilling people into trying to find a way, you'll find them attaining much more as they go and progress doing math than the ones that have always learned a technique. Because learning a technique will apply when you remember the technique. Being able to break down a problem will get you more in the longer term. So especially the ones that are going to do math in their life, it's much better to be able to understand things than just learning them by heart. Saying that, if you're only there to get your exam and move on, learn it, practice it, get it out of the way, it's probably an easier way. Okay, but just in case one day you get into this and you say, oh, I can't remember what I need to do. I know how to expand. I know how to look what should be what. And then you've got your answer there. Okay. So it's just a tip in case one day you can't remember. So you would get 1 mark to write x plus 3 square. And then the second mark would be to do the -2. Okay.
Yep.
So let's move on to the next part. So here we've been asked to simplify. So don't worry about this. When you see x different than -4, it just means the denominator can't be equal to 0. So you can ignore that portion. I don't know why a lot of my students sometimes get confused by this x. So you can even hide it. Okay, it just means for this to work, you can't have x equal to -4, because if you do -4 plus 4, it's 0, and we're not allowed to divide by 0. It comes with an error. Okay, so ignore that bit. Now what you've been asked to do is to simplify this. X plus 4 square is just x plus 4 times x plus 4. Now that we've got our factors at the top and at the bottom, you can just cancel them out by just saying I've got x plus 4 at the top and an x plus 4 at the bottom. That can go because that divided by that is 1. And your final answer is just 4x minus 3 divided by x plus 4. Yeah? Make sure you've got the fraction sign all along the 3 and the 4, or you can just put the brackets. So let's see how they mark this one. To get the mark, yeah, you only get 1 mark by giving the answer like that. Again, if you put the brackets, that's fine. You still get the mark. It's the same thing, but with the brackets. Okay, so it's 1 mark only. Write each of the following as a single fraction. Kiss and smile. Again, ignore that portion there. It's just telling us that we can't have a equals 0 or b equals 0. So that would be 3 times b minus 5 times a divided by ab. Yeah? 3b minus 5a divided by ab. For this one. For this one is f over 5 divided by e over g. We said when we divide two fractions, what do we do normally?
Put the second in times.
Yeah, so you change the divide sign as a multiplication. So f over 5 times g over e, and you flip the second one, yeah? And now you can do your kiss and smile. So it's fe sorry, that becomes FG. Kiss and smile only works when you've got add or subtract. So FG divided by 5E. That's your final answer. Nothing we can simplify here. Yeah? And if you want to be pedantic, you can add now E different than 0. But you don't need to do that. That's for the higher student. Okay? It just means you've specified that I've got this function. Not only G can't be equal to 0, but E can't be equal to 0 either. So let's see how they mark these. So the first one, if you get AB, that's 1 mark. And if you get your 3B minus 5A at the top divided by AB, that's your second mark. Okay, so AB just means you've got a common denominator. Okay. Here you get your first mark by changing the divide to a multiply and G over E, and your second mark by stating that F times G is just FG, and 5 times E is just 5E. Okay. So here we are asked to calculate a gradient. So if you remember well, the formula for the gradient, M, yeah, so we used to say y2 minus y1 divided by x2 minus y1. So that's the quick and easier way to do. So you need to pick x1, y1. So we're going to pick point P to be our x, y11, and x2, y2 are going to be the second point. Okay? And we just go through the process. Y2, which is 3, minus 4 divided by 6 minus 5. Minus becomes plus. Okay? Because technically minus 4 is minus 1 times minus 4. When you time 2 negative, it gets positive. So 3 plus 4.
7.
Yeah. So that would be 3 plus 4, which is 7. And at the bottom, 6 plus 5. 11. The good thing is both are prime numbers. I just leave them as 7 over 11. Okay? So, if during the exam or whatever what you're doing, you get a bit of time and you think, oh, I want to check this. Did I got it correct? Is it y2 minus y1? Is it x2? Imagine you get a blank. This is your best friend. You just go on your paper. Minus 5 minus 4, so that's about minus 1, minus 2, minus 3, minus 4, minus 5, minus 1, minus 2, minus 3, minus 4. So I'm about here for my first point. So you just say this is P. This is if you get a blank, right? You can't remember the formula. Remember, there's always a way. On the other side, you go 1, 2, 3, 4, 5, 6. 1, 2, 3. Then you go there and there, it's about there. So I've got my point Q. I've got P, I've got Q. I'm going to try and draw a line connecting them both here. So you do this. First thing first, I gave my answer as a positive gradient. Am I going up? Yes.
Yeah.
Yeah.
So positive, good. So I'm halfway there. Remember what we said? It's how much you're going up by along how far you're traveling. So if you look at it, we went from -4, which is 4-digit, 5, 6, 7. So that's a 7 unit there. By adding them, you've got a step of 7. Here I've got 1, 2, 3, 4, 5 plus, so 6, 7, 8, 9, 10, 11. 11. That is your gradient. M equals 7 divided by 11. I didn't need to remember it's y2 minus y1 divided by x2 minus x1 because I know it's a slope and it's by how much we're going high by. Remember the horizontal displacement divided by how far I've traveled. So if you understand that a gradient is a steepness, I've been given 2 points, and you can quickly draw this, you've got your mark there, and you didn't have to remember all this. Okay?
Is there a formula table in this assessment? Remember we were talking about it last week?
Yeah, for the volume, if they ask you calculate the volume of a sphere, yes, they will give you the volume of a sphere. You'll get your
Okay.
formula sheet. Okay?
There'll be something we have to remember though. Is that right? Yeah, there'll be something we have to know if in the exam or the assessment, sorry.
Yeah, the gradient one we'll need to know.
I'm thinking about the
Yeah.
volumes.
So the gradient y2 minus y1. So Kirsty, you said we need to know. But if I don't remember, I'm going to start drawing.
Yeah.
And then I'll be able, so do I really need to know? Yeah, if I want to do it quickly. But can you see why someone, after not using this for a while, might think, oh, it's x2 minus x1. Oh, I can't remember. I've learned so
Yeah.
many things. I'm studying English, I'm studying math, I'm studying geography, and all my exam on the same day. And how many kids would come and, oh, I put the x at the top. Whereas when I show them this is what you do to get a gradient, they go, oh, I've checked. Oh, I think that's what it is, going up by how long I've traveled. And that stays much better than X and Y's and 1s and 2s.
Yeah.
Okay.
Okay.
So it's just an idea. I know sometimes we have, it's a big curriculum, but I always try to give a visual thing and I tend to take my time explaining them because that's the best way you retain is through understanding what you do, not through learning by heart. You know, I can tell you that I've learned the First World War and Second War when they started and finished, but that's probably about it in my history. Yeah, there are other dates like you would know, but learning by heart doesn't cut it. Okay. So the volume of a sphere, I think we looked at it, was 4/3 of pi r cube or something. Yeah. Can't remember now. I would need to look at my, but I think that's about right.
4/3 pi r cubed.
Yeah. It's got to be
4/3 pi r cubed.
It's got to be an r cube to get the volume, centimeter cube. Okay, if it was a cone, I'll get the area times the height. But yeah, this will be given to you. They've given you 2.3. You've got your calculator. Unfortunately, 2.3, you've got to put it in your calculator, 2.3 cube. So let's see what we get. So first of all, your mark uses y2 minus y1. Did you see? They'll still give you a mark or equivalent. To me, that is equivalent. That is equivalent to someone who couldn't remember that. you would still get a mark if you show me what you've done, and then putting 7 over 11, whether you do it that way or you do it by doing, you'd be surprised how many people still struggle with 3 minus minus 4 to remember that it's 3 plus 4. Did we have to do that here? No, we just had to count.
No.
Okay, so 4/3 pi r cube is the formula, then, or equivalent. I don't know if there's an equivalent for that, but there's only one formula for the sphere, to be honest. And then they've told us to give the answer correct to 2 significant figures. So the first time we did it, we got 50.939. So it's a bit like rounding it with no 0 decimal or to the first unit. So 50.939. So if I use my calculator, 4 over 3 time shift to pi time 2.3 square, I get 22 point, what? Oh, it's cube. I put square. Cube.
I get 50.96.
So 2.3 cube. So I get 50.965.
Yeah.
Yeah, so they probably use 3.14. But 965 should round to 51. Yeah. So these are probably old books where they used to use 3.14, or maybe they didn't have. So 50.965, and that is 51 if you give it to 2 significant figures. Okay, yeah, that's why they said 50.939 or equivalent. So if someone used 3.14, they would still get the mark, or someone just use the pi in its in his or her calculator. Okay, so that's how we would get. How many more questions on that? Yeah, there's a couple of more questions. So in this one, we're looking at reflex angles. So first of all, reflex angle is bigger than 180, so that's why it's 240. The logo is a sector. Calculate the length. So length of an arc. So the first thing I put in my head is arc pi d. If it was area, it'd be pi r square. Pi d. Now I've got 240 degree. If I had a full circle, it'd be 360. So I've got a fraction of a full circle, and the formula is the angle divided by 360. Yeah? Time 240 divided by 360. And that should give me my arc length. So pi d, if the radius is 6.2, so I would put here r equals 6.2, d equal double that.
12.4.
12.4, yeah. So that's you. You've got everything you need. Arc length would be shift to pi time 12.4 time 24 over 36 or 240, and I get 25.970. So did they ask me to round it? So
No.
you can just put 25.97 and you just put next to it 2 decimal place. It's up to you. You pick whatever is the easiest. Next question. Cyril wants to jazz up the logo by outlining it with colored rope. He buys 20 meters of rope. How many logos would he be able to make up? Okay, so have a look. We've calculated this. He wants to put a rope, not just round this, around this, and there.
You have to calculate the area of the whole sector first.
The perimeter, you mean?
Yeah, the perimeter of the
Yeah.
area.
So basically, the first thing you would do is that 25.97, you need to add 6.2 and 6.2. So you need to add 12.4 to it. So whatever you got, you do plus 12.4, and now I'm getting 38.37. Okay, so now that I've got 38.37, what is that? Centimeter. It's got a wee logo. Now you've got to see how many 38.37 can you cut from a 20 meter. But what is 20 meter in centimeter?
200.
So remember, 1 meter has got 100 centimeter. Think about the ruler that you teach. Yeah, so if 1 meter is 100 centimeter, 20 meter would be 20 times 100, which is 2000. Because you can only divide centimeters with centimeters to cancel them each other and give me a number. So how many logos? You do 2000 divided by the answer, and the answer is 52.12. So remember, this is now you're going to use your judgment. The question is, how many logos? I'm not going to cut 0.12 logo.
52 logos.
Yeah, so the answer is 52 logos. And you need to state that. Because if you just put 52.12 logo, then a 0.12 logo is just a small bit here, which is not a full logo. Because they've asked us how many logos. So let's see how they mark this. Correct ratio, yeah. 240 divided by 360. Then time pi times 12.14. That'll be your first mark. Second mark, 25.957 or equivalent. So they've used 3.14. Then this is what we call a reasoning mark, where they put the hashtag 2 and a hashtag 2. So you've got 2 marks of reasoning. So they expect you to know that 20 meter is 2000 centimeter, or you do a division somehow. You've got to divide. And then the second one is, instead of 52.63, or we got 52.12, you need to state that you can only cut 52 logos. And during this unit assessment, you need to score some marks in terms of reasoning. It's not just the calculations. Okay, so you need to come up with a strategy telling whoever's going to mark you what you're doing. And then you've got to do a wee interpretation of your answer by knowing that you can only cut full logos. Okay?
Yep.
Yep.
So it was a bit tricky, but you can see how a bit of problem solving here.
How long did you say that assessment is in?
So it's about
like,
yeah, you can you can take the time that you need. It's just like we need to be out of there for a certain time, you know.
will there be the same amount of questions in that as what there is in this? Is this
Yep.
like a good example of the kind of thing will be asked?
Exactly the same.
Okay.
So we've only got that last question.
Right.
And remember,
Okay.
I'm going through it and I'm walking you through it. I'm giving you, if you can't remember this, try this. You'll see yourself, if you've done those 3 and you can do them, you'll go very quickly and you'll go, this is a bit strange. But take your time, double check, And usually if you see something that you're not too sure that you've done wrong, then you can correct it.
Yeah.
So let's have a look at that last question. Sherbet in a sweet shop is stored in a cylindrical container. So the sherbet is sold in conical container with diameter 5 centimeter and height 6 centimeter. So the first thing first is the shop owner thinks he can fill 260 cones. So I've got a cone and I've got a cylinder. I'm thinking, oh, I need to find some volumes here. So how many of this how many cones can I fill in with the content of this cylindrical container? So first of all, I need to calculate the volume of the cylindrical.
Volume.
And we say it's area pi r square times the height. So R is 10 because D is 20. So pi times 10 square, which is 100, times 32, yeah?
Mhm.
And I'm just going to write it as 32 times 100, which is 3,200. Pi, I'm going to leave it as pi just now. You're going to see why, centimeter cube.
Where are you getting the 100 from?
R square, so 10 times 10.
Oh, right, squared. I missed
Yeah. So the area is R square. To get a centimeter square, time another centimeter to get your centimeter cube.
that. Right.
Okay, so I'm going to put a wee line here to show that this is 10 square. Now, 3,200 pi centimeter cube. I'm going to tell you why I'm using pi, right? This one, for the cone, volume of a cone is a third, yeah?
Yep.
Pi r square time the height as well, but this time it's a 6 centimeter height. So 5/2 square, yeah?
Mm-hmm.
So just go 1/3 pi 5/2 square times 6, because it's 6 centimeter, yeah?
Mhm.
So 5/2 square is 25/4. Because you need to square the top and square the bottom. Or if you want, you can just put 2.5 square. It's up to you.
6.25.
So you've told me 6.25 pi, yeah?
Mm-hmm.
Okay, so first thing first, I've got a third, 6 divided by 3, 2. So I've simplified my life here. So I've got 25/4 times 2 times pi. Yeah?
Mhm.
So look at that 2, look at that 4. Can I simplify it?
Yeah, 2.
Yeah,
2.
so that's 2.
5 pi.
25 divided by 2 pi. So now, if I want to know how many of these can I fit in that big one, I need to divide 3,200 pi centimeter cube by 25/2, or like you said, 12.5 pi centimeter cube. So far, so good, yeah? Centimeter cube, we can simplify them. Pi, we can simplify them. If you've got your calculator, you just type 3,200 divided by 12.5, and I get exactly 256.
I got that exact answer, 256, but with different numbers for both the cylinder.
So basically what you've done 3,200 time shift pi, and then which give you a massive numbers. You've written it, and remember, the more you write, the more you've got the chance to make a mistake, okay?
Yeah.
But that's okay, as long as you get it right, or you double check. And whereas, because I knew I was going to divide pies with pies, my pies are just going to cancel each other, and I get a very easy things to type in my calculator.
Yeah. Yeah.
But you did get it at the end. It's just I got it by maybe having less chance to make a mistake, if you see what I mean.
Yeah, of course.
So, see your 25 over 2, I get that that's how you get your 12.5, but what happens to that pi?
So there's the pi there, 12.5 pi.
Oh, right, so you're actually right, okay.
Yeah, I've written it
I
as
didn't
a
realise
fraction.
you scored that out, you've actually scored both of them out.
Yeah, so basically, because I'm going to divide a volume of a cylinder, and I know it's got a pi in it, by a volume of a cone that's got a pi in it, I'm thinking, oh, those two pi's, it'd be nice if I can just cancel them, each other. The same way I'm canceling centimeter cube by centimeter cube, because you don't want to end up with 256 centimeter cube. That doesn't make sense. You've been asked to see how many cones can you fill. I can fill 256 cones, but not 256 centimeter cube cones, you see?
Yeah.
So that's why by doing it this way and keeping the units, it gives me a better feeling of my answer being a plausible answer. Yeah.
Yeah. There is something that's ambiguous.
And then the other thing to look at is, you can imagine a 6 centimeter by 5 centimeter. Here I've got 20 centimeters, so you can fit quite a few wee cones in there. And you can put them upside down, so you can see. And a third, it's as if we've taken a third of a cylindrical. Yeah, so 256 divided by 3 is about 85. So if this wasn't cylindrical, if this wasn't conical like cylindrical, you'll be able to fit less of them.
Yep.
And I think it'd be harder, because you'll have a lot of void, you'll have a lot of empty space, if you see what I mean. Whereas here, it's a liquid that is in there, and you just fill in each cone with the liquid. So you didn't have to change these into milliliters, because my centimeter cube just cancel each other.
Yeah. And you
Okay.
just yes or no to finish it as well.
Yeah. And let's see how many marks that was. So that would be, so you've got a bit of reasoning as well. So substitute relevant values into correct formulas. So by just substituting R here and R, so that would give you the mark there. Then 10,048 or 3,200 pi. So there you go. You still get the mark by writing 3,200 pi. And the next one is 12.5 pi. So you still get the mark because it's an equivalent. So, but if you decide to go for the full thing, that's fine. So now the question was, the shop owner thinks he can fill 260. Is he correct? So the last mark to get is to answer this question. He's not correct, because he can only fill in 256 cone. So he's wrong. So remember, we need to answer the questions in math. Me just writing 256 and stopping there won't give me that last reasoning question. Okay.
Can you see if you're like running out of time, you've got a question like that and you're happy with your answer, can you literally, if you're running out of time, just write he is wrong and you'll get that mark because you've already put the answer?
Yeah, you can just say he's wrong. Yeah,
Okay.
I would say he's wrong. What I would say is 256 is less than 260, for example. You can
No,
just
I'm just
say,
thinking if I'm checking it at like the end of an assessment or an exam or something like that, and I was just panicking and running out of time,
okay.
just quickly while they're bringing in the papers, if you're noticing, oh sugar, I should have wrote yes or no.
Yeah, yeah, that's fine. You'll get the mark. But imagine if for some reason I had made a mistake somewhere and I had here 280. So if I put 280 and I come back and give him a paper and I put a no, I won't get the mark because your answer should match what you've answered,
What your reason is.
yeah, what you need to reason based on the result that you found. Okay,
Yeah.
so you would still get the mark with the reasoning
Yeah.
based on your answer, which is why I was
Yeah.
telling you there, the math. Yeah.
No, it's just like wee silly things like that that I think that I probably oversee. Like I'm more concentrating on what the actual questions
Okay.
asking, as in like numbers wise and formulas, and what the physical question is asking. Is he correct? Is he not?
Okay.
How?
Yeah. Okay. So I think we're going to take 5 minutes break. Is that okay? Then we'll finish
Yeah.
the other one. And that means the third one you'll be able to practice it yourself.
Mhm.
And then send me any questions. And then when we come back next week at Annie's Land, we can quickly go through the third one if someone's got any questions.
Yep.
Okay.
Okay.
So I think I need to stop